Good afternoon, everyone. I hope everybody is safe and in a quiet place. Welcome to the third webinar on the final one on colibacillosis. And today it's about control and prevention. Prevention is key, and I would like to give the floor to Hilde. So all be silent, and if you have a question, we prefer you drop it in the Q&A box, and then we can go over the questions afterwards. Thank you. Enjoy the training. And to be complete, in the today or tomorrow, you will receive the additional invites for the next webinars. The next 3 webinars are on mycotoxins, and they will be given by Professor Antonissen from the University of Ghent. And then we have the 3 last sessions. These will be given by Hilde from Vetworks on salmonellosis. So, good. The floor is yours, Hilde. Thank you.
Thank you, Eric. Hello to everybody. Good afternoon. I'm glad you could join for the last webinar, because in fact, this is the crucial one. How are we going to control and prevent colibacillosis? So we talk about treatment and control and prevention. So first, treatment, because yes, colibacillosis can make the birds very sick, so we need to treat. But of course, prevention is always better. So we'll look at the different syndromes, neonatal colibacillosis, respiratory, and then the reproductive tract colibacillosis. And then the last part, I will leave to the people of Zoetis. They will explain about vaccination for E. coli. So, in fact, if you have the right antibiotic, E. coli very often responds very well to the treatment. Of course, if there is no resistance. And the thing is that we see that more and more we find multi-resistant E. coli distributed not only in our poultry, although we do seem to see a lot there, but maybe that's also because we test a lot on our poultry, but also in cattle, in people. So resistance is an issue, but there can be other reasons why your antibiotic is not working. Sometimes it's because, remember, we said you need E. coli. Very often you have other co-infections. But also triggers. There are some inducing factors. It can be in a house, draft or bad ventilation, a lot of dust. Those can be triggers for the infection that are constantly there. So you can treat for the E. coli, but as long as these cofactors are there, you will not solve the problem. Remember that we said E. coli is always present in a poultry house. As long as it stays in the gut and in the litter, that's not a problem. But once, like for example, if you have a lot of ammonia, that's one of the triggers, then the E. coli will be inhaled and start to creating systemic infections or local infections in the respiratory tract. Of course, a lot of less sensitivity for antibiotics will also depend, and we will show that the more you use an antibiotic, the more you get resistance. So the resistance will also, or the sensitivity will also depend on the type of antibiotics that you use. That's why it can be different in different countries, and we cannot give general advice on that. Again, make antibiograms. Then another reason why your antibiotic will not work is if the infection pressure is so high. Then your antibiotic is never going to be the full solution. Another reason is that like for example, with chronic respiratory disease or vaccine reactions also after NCD. In one flock, there are different stages of the disease. Remember the first day we showed how an air sac infection develops. It starts with foam and then you have more exudate and so on. So in that same flock, you will have birds that are in the first stage. Those will probably be successfully treated. But you also have birds that are in a later stage where there is too much inflammation, too much purulent exudate, so that your antibiotic will not work. So that is another reason. And then, yeah, wrong application. We sometimes see that maybe the medicine quality is not good, or the dosage was not respected, or the water where you put it in isn't a good quality. That can also be a reason why you are not successful with treatment. I want to give you some considerations from my experience for all these different kinds of treatments or syndromes that we treat. In neonatal colibacillosis, this is one of the reasons for first week mortality. And it used to be common practice to say, okay, to try to avoid that, we will give some antibiotic in the first days to reduce that first week mortality. But I think that more and more we realize that this is not a very good idea or even a bad idea because what more and more we know how important the microbiota in the gut are for development of the gut, development of the immune system. And what are you doing if you give a broad spectrum antibiotic in the first days? In fact, you are killing all those bacteria, which we know are very much needed and very, they need to be there. So we have to avoid that. The other thing is, okay, sometimes you will have to treat. If you see that chick quality is really bad, then you might want to do a treatment, but still you will see some birds will recover. They will always be weaker. They will have a lower level of maternal antibodies, so they are more susceptible for other infections that are there, viruses, but also other bacterial infections. You will also see if you need to treat that you have loss of uniformity. You will have some of these weaker birds that probably will still die anyway. Increased risk of resistance to antibiotics. And yeah, the best thing is to make good selection. And talk to your hatchery, because as we explained already, and we will come back to it, the hatchery has an important impact on that neonatal colibacillosis. And then for the respiratory colibacillosis, you have to make sure that the viral agents are controlled. As we saw in the example that Tiago showed yesterday, is that, okay, colibacillosis, that is what you see, but behind that are viral agents that are not well controlled. So as long as you don't control those, you will not have good response to antibiotics. They can only save birds at early stage of the infection, as I said before. So if you look at treatment for E. coli, and this is now an example from Belgium, but it applies to everywhere, in fact, in the sense that we must rely on antibiograms to make our choice. Like here in the formularium from AMCRA. AMCRA is the institution that is trying to have impact on antimicrobial resistance. So they are, it's a project in livestock and also in other types of animals to see if we can reduce antibiotics. And they made these formularia. And we see here for E. coli that the first choice are sulfas with trimethoprim, lincomycin with spectinomycin. And then the second choice, and the choice is first of all determined by rate of success, but then again come other things like we don't want to use too much broad spectrum, and we don't want to use critical antibiotics for humans. So that's why colistin is in the second choice, where very often you have good results with colistin. And then the third choice are those that are really critical antibiotics and too broad to use. So again, my advice, try to find ways to do culture and to make antibiograms for E. coli. So if you have sensitivity to your antibiotic, you will have good success. Unless there is a resistance, or that E. coli is not the cause of your problem. We saw that, for example, Colibacterium annatis, but also some Pastorella, can give you the same signs, and you will be able to isolate an E. coli there, but it's not the root of your problem is another one. And the sensitivity for Colibacterium annatis is different than for E. coli. Okay, that's treatment, but in fact, what we try is to prevent. We will always have to treat in some instances because we don't want to let the birds die if we can help them. But the key to control colibacillosis is prevention. And there you have two ways. I think we have very efficient vaccines, but I will leave it to Hussein to talk about that. What I want to highlight is other ways of prevention. So we'll look at the three syndromes again, neonatal colibacillosis, where the root of that or the cause of that E. coli getting close to the egg or the embryo lies at the breeder farm or maybe in the hatchery. And then again, there is also a place to improve the brooding process. That will also reduce your first week mortality due to E. coli. For respiratory, of course, colibacillosis management of all those triggers are also very important. Manage the climate in the house, make sure there's not too much dust, etc. And also vaccinations. Now I'm not referring to vaccination for E. coli, but I'm referring to other vaccinations. Remember we said try to find the cause, and that's why you need to have a good vaccination program. And also making your program so that it doesn't do more harm than good. Sometimes we see vaccination programs with too many vaccines in a short period, all for the same targeting, the same respiratory tract. That is not okay. And this will also give you more problems with E. coli. And then for the last, the septicemia, the infections of the reproductive tract, there are also some things that are important to during rearing and production in the management that you must that you can do to prevent colibacillosis there. So if we look at the neonatal colibacillosis, we know that the quality of the day-old chick is very important. There are many risk factors there. It's not only hygiene in the farm, in the hatchery, it's also the immune status of the parent stock. Do they have high enough titers against the different diseases to protect with maternal antibodies that small chick? The age of the parent stock, very young birds maybe don't have high titers enough, or older flocks might, the titers might have gone down so that the maternal antibodies get low. Disease management in the parent stock, of course, is also important. If you can avoid Colibacillosis in the parent stock, it will also help less contamination of the eggs, less contamination going to the hatchery. Then also the transport can be not only hygiene, but definitely the conditions in the truck. How long does that take? Does it take hours to get, more than a day for the day-old chick to get to the farm? All these things are to be considered. Feed and water, is it immediately available to those chicks? And then the incubation process is also important. We know that good or bad incubation, too hot, maybe too long process, a lot of things can go wrong there, and that can all affect the quality of the day-old chick. And then the immunological capacity of that day-old chick. If that can depend on also during hatching, but also the development immediately after hatching of the immune system can be compromised. So the question is, all these different risk factors, can we manage that without antibiotics? Or what can we do to protect better the day-old chick against neonatal colibacillosis? So we want to improve day-old chick quality. And as I said, that starts at the breeder farm. Biosecurity and immune status of the breeders is important. So you need to have a good vaccination program, as I said, not only for E. coli, but also for the other co-infections. There's also a big responsibility for the hatchery. Improve the sanitation and hygiene at the hatchery. Also the biosecurity there is an important factor. We can also improve the chances of, or the quality of the day-old chick by providing it, and definitely when we talk about avoiding first-week mortality, by early feeding. And there are, lately we realized that early feeding is very important for development of the intestinal tract and the immune system. And there are many ways to do that. There are systems in the hatchery, also during transport, you can put some gel in the box or some, substances that can hydrate the chicks already in the box so that they can pick something. And then, of course, the sooner they get to the farm, the better. And then good startup and brooding. The chicks arrive at the farm if already it's not warm enough there or too warm, or if there is too much carbon dioxide there because of the heating system. Those are all things that are not going to be good for that day-old chick. And we have to, the first days, they are so fragile that we really need to take good care during those first days of brooding. So if we look at the breeder farm, I said the quality of the day-old chick is affected by the breeder farm. So we want to definitely think about and protect the chicks for vertical transmitted diseases. Then vertical transmitted diseases is MSMG. I put E. coli here because, as we explained, it's not really, through the bloodstream, but it's because of E. coli is on the surface of the egg, and then gets sucked into the egg when it cools down. Rio, adeno, chicken anemia virus, we know that these are vertical transmitted diseases and also immunosuppressive. So try to protect the breeders for that if those diseases occur in your area. We have to regularly check the immune status of the breeders. We sometimes, because, well, the reason is that we want to give the most possible or high titers of maternal antibodies to the day old chick for all the pathogens that are present. So you can only know what pathogens are there if you regularly monitor, and that can be done by serology. I think Thiago explained that yesterday. And then again, at the aim is that once the breeders start producing day-old chicks, as soon as they start laying eggs, we would like the titers of the breeders to be high enough to transfer maternal antibodies to that day-old chick. So for some diseases, you will have to maybe vaccinate again during production to keep those titers high enough. For some diseases, you have also field infections that can be a booster, but sometimes you need to check, monitor, and then see if you can do something to booster those titers. You also have to make sure that the vaccines that you use match the serotypes of the field strains, and that's why also we monitor. For example, for infectious bronchitis, we have many variants, so you have to monitor that. And then management, really management, is about biosecurity, is about not sending dirty hatching eggs to the hatchery. We do not want floor eggs. In fact, you should never use floor eggs for hatching, but sometimes, or very often, if you don't have enough hatching eggs, you will still use them. It's not a good idea, but try to avoid floor eggs. And that can be done by training the pullets at the start of lay to use the nest. It takes some work and from the farmer the first days to put all these hens in the nest boxes to avoid these floor eggs. But it's worth it because it's going to avoid floor eggs later, so dirty eggs. And then also sometimes even eggs that are not floor eggs get dirty because the nest area is not clean and because the transport belt also is contaminated, and contaminated with dust, with debris of broken eggs, etc. Very good to for E. coli to grow there. And then the hatchery. The hatchery is a very, I would say dangerous place in the sense, if we look at biosecurity, if we look at transfer of infections, because you get hatching eggs from different breeding farms. They all come together in one hatchery, and then they distribute chicks to different broiler or layer farms. So the hatchery is really a capital place to avoid cross-contamination. Because we also know that the microbiota that the chick has, a day-old chick hatched in the hatchery, is not always only related to the breeder farm he comes from, because it can also get, there is also cross-contamination in the hatchery. All these eggs go in one hatcher and they will all hatch together. So that is a dangerous place for cross-contamination. So first of all, biosecurity should be tight, and it should be structural in a hatchery. There should be no way that people can go in the hatchery without taking a shower or without going through all the measures that need to be done. So you can make that structural. If there's no way to pass inside except if you pass through the shower, that is a structural way, so everybody will have to go through. Cleaning and disinfection, of course, is also very, very important in the hatchery, and the layout of your hatchery. You have to make it logic so that there is no possibility to cross from dirty to clean. Handling and storage of the eggs in the hatchery to limit the cross-contamination between breeder farms in the hatcher. You have to, as I said, the layout of your hatchery is very important. You need to have separate areas for handling the eggs, and then that is where they come in. The eggs, that should be very separate from the end of your hatchery, where you have the hatched chick and the hatched debris, of course, very contaminated. So there should be no possibility for the eggs to be contaminated with that. Eggs must be sanitized before they go in the setter. We all know that, but sometimes they are even, or like in Europe, it's common practice to already disinfect the eggs immediately when they arrive at the hatchery, and sometimes even at the breeder farms. So as we said, no dirty eggs in the incubator, and all the materials that you use, the trays, the trolleys, everything should be split spots. It should be very clean. So here you see how eggs are handled. So keep them clean. They are already disinfected here. Then they are put, before they go to the setter, they can be sometimes disinfected again.
So
you have
in the hatchery, there are two factors.
Sorry.
Important factors here.
Yeah.
One is
you have eggs arriving in the hatchery. They will be disinfected before they go in the setter. That's the first 18 days. Also here, of course, single stage is always better than multi-stage hatching. Multi-stage is you have different ages of eggs in the same setter, and then you have to start changing and accommodating to the temperature. The ages will be different, so more risk of cross-contamination. And then again, after going, sorry, could you mute your mics, please? Then from the setter, they are transferred to the hatcher at 18 days, and then they hatch between day 19 and day 21. And at transfer, you remove the infertile eggs and you disinfect. Then something that is very important, a source of Colibacillosis, of infection with E. coli, is the navels. So they should be really well clothed and dry, or the day-old chicks can go to the farm before they leave. It should be, and that's why we see that less problems with Colibacillosis when we do in-house hatching. That is one way of incubation, of early feeding, is in-house hatching. So what they do is you place the eggs in the house, you put the litter, then you place the eggs, and you put ovoscans. Those black things that you see here are ovoscans. They measure, just like in the hatcher, they measure temperature, humidity, and if there is something wrong with that, it can be adjusted. But the difference is that here, all the chicks will hatch at their own time, maybe at day 19, day 21, but immediately they can go to eat and drink whenever they are ready. So here is the drinking line and there is the feed. So the chicks can go there. After that, the non-hatched will be removed. And so this is an innovation. It's called nest-born. Of course, you have less risk of cross-contamination than in a hatcher. First of all, the house is much bigger, so any infection that is there will be diluted. The chicks are less stressed because everybody can be born when it suits him and everybody can go and eat. So early intestinal development and immunity. So these are the advantages of early feeding. As I said, it can be in transport, it can be done in the hatchery, in the hatcher. But those are the advantages, is that you the maturation of the intestine is much quicker than if you don't give early feeding. You see if you withdraw feed for 48 hours, they will have a really lower weights at 7 days, and that is something that they will never pick up again. Yeah, so that was prevention of neonatal colibacillosis, and then respiratory colibacillosis. Try to find the real cause, the virus or another bacteria. It's not because you find E. coli that is the reason of, or the primary reason of the problems that you have. Reduce the bacterial load in the environment. You can do that with good litter management, good ventilation. We want to avoid dust at any time. Ammonia, because it's going to irritate the respiratory tract, and dust because also it irritates, but it carries a big load of bacteria. So focus on biosecurity in general, but specifically cleaning and disinfection is important, and very important, I would say, is water treatment, because very often people don't realize that water is bringing around all these bacteria. If your water is dirty, it's carrying loads of bacteria. Correct vaccination, as I said, don't give everything that is necessary, but make a good program, not too crowded, and look for the right vaccine. Mycoplasma is still a big problem in many places, so try to have a good control a program for mycoplasma. And in case of cellulitis, remember this, when you have all these under the skin exudate, then you must look at stocking density and avoid, if they are not too close together, if the density is lower, they will not crawl over each other to go and feed. And some breeds can be more resistant for some diseases. But that is not always very clear. Is it really resistant, or is it because we keep them in different ways, they grow slower? So that is something to see. And then the last syndrome, very often death in when the birds go to peak of lay, in layers or in breeders. And very often, if you see something like this, no way is an antibiotic treatment going to do anything here. And the other thing is that also we have very little antibiotics with 0 withdrawal time, meaning that if you want to use the eggs, you need an antibiotic with 0 withdrawal time. So that limits the antibiotics that you can treat with. And the other thing is that, why do we get these egg peritonitis? Also has to do with management of the birds during rearing and during production. But I want to show you this graph, because what we see here is growth, and here the age of the birds. So they start laying at about 19, 20 weeks, And that is still a critical period in growth for these birds, because in fact, they only become sexually mature around 23, 24 weeks. The other thing you see here, so the organs are not fully developed, and you also have accumulation of fat. And those two things play a role in development of egg peritonitis. And what you should not do is try to get these birds in lay too quickly. Again, first, drinking water sanitation, very important. But then management of the body weight and the uniformity is very important. And in breeders, we pay a lot of attention to that, but sometimes in layers is not so well checked. So do not start. How do you get them in lay, or how can you make that they go in lay later? Is by regulating the light. If you start photostimulation when the birds are like this, where you can see the ovaries are not developed, that is not a good idea. So you have to wait. Sometimes you just have to check. And here I show you the evolution of the ovaries, but also look at the body fat. That is also a good indicator to see how it's going, the body weight. So that was my talk for today about treatment and prevention of colibacillosis. So I don't know if you have any questions for me.
Hilde, I think it's best that we move to
because later,
Q&A
after the vaccine, I will talk about, answer the questions on my part of the presentation, and then everything to do with vaccination, that will be Zoetis that will treat those questions. Yeah, okay.
Thank you very much. Hussein, are you able to take over? Would you give it a try?
Let me look at the questions here.
Yes, hello Eric, do you hear me?
Do you want to take the questions now or afterwards?
Yeah. So do high titers of maternal antibodies affect the efficacy of field vaccine? A field vaccine, or you mean vaccination probably? Yeah. It depends on which disease you are talking about. We know that we have to look at, if you vaccinate for Gumboro, for example, you have to look at the maternal antibodies. And we consider that for some diseases, even if you have maternal antibodies, it is not going to interfere with the vaccine. Sometimes you need to repeat. An example, for Newcastle disease, the live vaccines you give on day one, they will still work and they will still protect because they provide local immunity. So there will not be an interference there with maternal antibodies, but you still have to repeat, because that is one thing. Another question, how often should we vaccinate? I will leave that to the Zoetis people. When we disinfect the eggs before they go to the hatchery, may it have any effect on the embryo? Yeah, well, yes, it could. That is why there are good procedures for how you do disinfection of the eggs. An example, formaldehyde, which is used less and less, but formaldehyde is embryotoxic. When you disinfect the eggs, then afterwards they go into a room where you use the formalin, and then you have to ventilate very well, because if the formaldehyde stays in the setter, for example, you get birds with 4 legs, you get twisted beaks, so you get all sorts of funny things with your chicken. So yes, that is important. It can affect your embryo, but that's why you have to have good procedures and good protocols. Thank you. What are the possible factors contributing for the reduced sensitivity of E. coli to antibiotics? I think the main one is resistance, as we know, is something that goes from one bacteria to the other. Like resistant genes can be passed on between Salmonella and E. coli, but also between, for example, a pathogenic E. coli and a commensal E. coli. So that is why, that is one way, one contributing factor is that we have E. coli in many species, so that is also going to contribute. The very important one is the more you treat with antibiotics, the more resistance you get. We also know that if you stop using antibiotics, I think there was a slide in the presentation of Tiago yesterday that is interesting, that the sensitivity of E. coli appears to come back if you use more vaccines. Because if your vaccine is successful, you will not need to treat with antibiotics. So the resistance in E. coli is going to go down. So I hope that answers the questions. The question, considering E. coli antibodies due to normal intestinal flora, can host serology be used in diagnosis and monitoring? No, I don't think that antibodies on Tuesday we explained, we are talking here about extra-intestinal E. coli that provoke systemic infections or in other organs, not in the gut. The commensal bacteria that are in your gut are not going to give you antibodies in the bird. No, because they are not going inside the bird. They stay in the lumen. Yeah, I think we talked about that. Could application of probiotics and phages in the environment help prevent emerging resistance? Maybe yes. The phages, we are involved in a project about phages. I think there is still some work to do, but it could be a promising thing. I don't think at this stage we have enough proof that it works, but it could be a promising thing. Probiotics in the environment, yes, they could help. One of the in the environment or in the feed, they can also help to establish a good intestinal microbial community, and also in the outside. If you can control the E. coli in the environment, of course, you will have less infections or the infection pressure will go down.
We have to start with Hussein.
Okay. So I want to thank you very much for your attention. It was a pleasure, talking to you from far. So I hope to see you back soon. Okay?